All right, good morning. This is a video recording made on Thursday, April 1st, 2021 for my physics CP students. This is the day where one of my classes attends class and my other class miss class because tomorrow is already a holiday, spring break, local holiday. So I wanted to record what I'm teaching today, and that's what this recording is trying to cover. So right now you're not looking at anything meaningful on the screen, but let's immediately start by saying I want to get you excited about astronomy today. So the first thing I'm going to choose to do is take you to a website called Astronomy Picture of the Day. They started this up before you were born. It says date launch June 16, 1995. And all of you are younger than that. And every day for all these years now, they've been choosing what seems to be a pretty picture and then posting it on their website for your entertainment, right? Education and entertainment. Looks like today isn't just actually, you know what? I forgot I had to take care of one little thing. So I need to pause this recording for a moment. Okay, here we go. So today, April 1st, 2021, it says rocket launch as seen from the space station, and it looks like it's on YouTube with music. There it goes. See it? Nice. This is sped up. You can see radiation hitting the upper Earth's atmosphere. The rocket just did staging. That would be second stage. The lights at the bottom are artificial lights from cities on Earth. Second stage burnout. All right, there you go. The little dot. I don't understand why it's as visible as it is. Nice. Okay. Pretty loud on the audio. Hope you could hear it. And that was the astronomy picture of the day. It was actually a video clip uh, recorded for the International Space Station. Very pretty. Now, the point is, at this website, when you go down to the bottom, you can search for different stuff, or you can bring up the calendar. The calendar says, okay, for the month of April, here's everything. Actually, look, for all the years that it's been in existence, from June, whatever that was, 1995, until today, there's a picture that you could look at. So I'm just going to randomly click somewhere on this thing, move the mouse, move the mouse, move the mouse, click. Okay, so I happen to pick the month of July of 2009, and here's little thumbnails of every picture from July of 2009, and I'm just going to randomly say, this looks pretty, what's this? So it is a photograph of the Great Wall of China in the foreground. Let me see if I can, usually on these pictures you can zoom way in on them. So the Great Wall of China is in the foreground. And then there is the moon during a total solar eclipse, blocking the light of the sun. So this is actually a daytime photograph. The moon happens to be right in front of the sun at this moment that the picture was taken. This is a beautiful event in nature. It happens maybe once every 18 months or so on average somewhere on the planet. You should go see it. And because the moon is blocking the sun's light, the sky is dark enough here in the middle of the day, well, morning or evening, whatever this is, that you can actually see a dot there that's a planet. There's another planet. There's a planet. There's a planet. There's a planet. I think I have a little embedded webcam, eraser, stickers, rectangle, and a pen. Great. Well, so there's a random example of astronomy picture of the day. Normally, I make the students look up their birthday and say, oh, yeah, hey, Mr. Turk, I want to see my birthday. I was born in, well, let's see, if you guys are around 16 or 17 years old, when were you born? 2002? What would that make you? Let's see. So 2011 would be 10 years old, 11, 12, 13, 14, 15, 16, 17, April of 2004. Okay, and which one looks pretty to me? Oh gosh, pretty to me is different from pretty for you. So I will just say, here's one. April 4th, 2004. Maybe it's your birthday, and I forgot to read the photograph of it. This one is clearly on Earth. Blue sky, snow on the mountains, greenery, a little bit of liquid water evidence, not to mention, human activity, pretty obvious here. So whatever this was, and you can zoom in on it some more, little solar array, some sort of weather station, looks like. This is an ammeter that measures the speed of the wind. This might be a probe of some sort, another probe, and recording, communication, power supply, equipment. Great. So I should back up and see, what does it say? The Lost World of Lake Vita. And then, if you're curious, you could read the text at the bottom. For you, that should be small font, so I'll read it to you. A lake hidden beneath 19 meters of ice and gravel has been found near the bottom of the world that might contain an ecosystem completely separate from our own. In a modern version of Sir Arthur Conan Doyle's classic book Lost World, NASA-funded scientists are now plotting a mission to drill down into the lake and remove a sample of water from the lake for analysis. Lake Vita, buried under Antarctic ice for over 2,500 years, is liquid only because of a high salt content that results from salt being expelled from water above as it turns to ice. And then it goes on. So there you go. Interesting picture. You can find one from your birthday. If you don't know who Sir Arthur Conan Doyle is, well, gosh, we could always click on it, right? So you click on the hyperlink and you say, oh, he's this author of many books, and some of the books you would recognize, right? So I clicked on them and nothing happened. Little slow on my internet over here. Let's click again because I'm impatient. Or you could go and Google it and say, oh, he's the guy who wrote Sherlock Holmes. At least that's what I'm expecting to come up when this link finally goes. And it's not going. Oh well, so much for astronomy picture of the day. And there are others. I guess I'll just do another random one. Here's one. April 10th, 2004, and it shows NGC 6946, which means New General Catalog. And you go, ooh, pretty. Every white spot is a star, yes. Now, this whole thing here is a galaxy. And we didn't know what galaxies were for the longest time, but now we know that what we're looking at is like an island universe, a spinning pinwheel of hundreds of billions of stars, and they have spiral arms that seem to be winding up, a galactic core, a halo of globular clusters, perhaps, different colors. based on how young the stars are. The spiral arms are where there tends to be new stars being formed. So these are baby stars here on the scale of the universe, maybe only 1 billion years old or less. Our sun is 5 billion years old, by the way. It's sort of a yellowish color. There's more to this picture. Like when you look at a star, notice that it's got these points sticking away from it. 4 points here, 4 points there. That is not in the star itself. That is in the optical system that was used to take the picture. Typically, this would be a telescope, and a telescope has multiple mirrors in it. To hold one of the mirrors in position, they use something called a spider. In this case, the spider has 4 vanes. And the diffraction of light, ooh, you studied light, waves. The diffraction of light causes some of the waves to pile up sort of opposite where the spike is blocking the light relative to the pinpoint of light that's the star image. So as a result, you often see 4 little spikes sticking out of this bright stars in an astrophoto. If you see 6 spikes, that means the spider had 3 vanes instead of just 4 vanes, set 120 degrees apart, which leads to the pattern of 6. If it doesn't have any spikes, that's a more expensive telescope in terms of optical design and construction. For example, catadioptric Schmidt-Cassegrain telescope would not have any spikes. We have 2 telescopes at school that would not have any of these little spiky things, and the other 5 would all have a, a pattern of 4 like this one. No, that's not true. We have my homemade telescope, which would be different. Okay, so the universe is out there. I could try to use astronomy picture of the day to teach you about just aspects of this, like Greek astronomy. If I do a search for that, what comes up? A listing of different photographs and explanations that scroll on and on and on and on and on. Let me see if there's anything that I really care about. What about, I used to teach, or that first day I lectured to you, I taught you about Aristarchus. Do I know how to spell him? Nothing found. So apparently it doesn't auto. Aristarchus. So if you put in the entire name, they've named some stuff after him. Which planet? Oh, this is on the moon. Let's do this one from November 8th, 1997. Title is Aristarchus's Unbelievable Discoveries, taken from a space shuttle. Oh, this is where he lived. He lived on the Greek island of Samos, which maybe is this one. I don't know which one is the Greek island of Samos. But this was a photograph taken by a crew orbiting the Earth, and it was on one of these small Greek islands that Aristarchus did his reasoning about how far away the sun is from the Earth relative to the moon. You might remember some of those stuff. Small island in the center. Okay. He lived from 310 BC to 230 BC, and you can read about it. So nice, right? Measured the size, distance to our moon, his discoveries. If we click on that web page, it's not found on the server. Nice. Okay, so what am I going to share with you students today is in a very complicated software program that you could get for free, and I'll try to demonstrate it to you. So it's called STK, If you go to their website, let's go to their website for a moment. Sure. The website is agi.com, analyticalgraphicsincorporated.com. Software for digital mission engineering. Oh, yeah. So what you're seeing is what their company deals with. So in the background, you can kind of make out satellites and ships and planes and missiles. You can try them out by downloading their software, and I'm going to now show you their program. So here it is. It's downloaded, it's installed, and now I'm going to launch it. So we have to wait because my computer's not that fast. And I hope I double clicked it correctly so that it actually launches instead of us just sitting here waiting. Let me try that again. Yeah, okay, it's launching. I think what I'll do is I'll show you how to use it to find the International Space Station from your home. Demo licenses will expire in 60 days. Yep. So what I'm going to do is create a scenario. You can only have, let's see, ISS from CHS. And let's make the start period, start time. Let's make it today. And let's make the stop time set to, I wonder if I can say 2 weeks. No, I can't. So let's try that again. And we'll just make it for tomorrow right now. Drats. So I haven't bothered relearning how to make it go for 2 weeks instead of just for one day. But it's thinking, it's reconfiguring, it's setting things up, getting stuff ready. Now this is freeware. Everything I'm showing you right now, it was developed by a small company working for the government, trying to make it easier for people working in aerospace to visualize what's going on and analyze what's going on. So right now you're watching the little blue circle go round and round and round. This could take all the way up until 3-minute break, the way we're going. Ta-da! Okay, so it's asking me what would I like to insert, this little pop-up menu. And what I'm going to do is insert a place from the city database. That's fine. Okay, so place is a type of object. I have choices, missiles, satellites, and the method I have choices. I'm going to put in a place, and so I click insert, and I'm searching for Cerritos. And it's asking like what country. Well, let's just search anyways. How many Cerritos is going to be? There's only one in the entire planet, and it's Cerritos, California, United States, at a latitude of 33.8 degrees north and longitude of 118 degrees west, and I like that. And I'll use this color to represent it. Ooh, I can choose other colors. And insert. Okay, now I'm going to close. And while I'm at it, I'm going to insert a satellite. So let's put in a satellite. And I want to select from the standard object database. And this is where things get really nasty because it doesn't work out very well. If I type in ISS for International Space Station and do a search, oh, it does come up. But what I want is one that is like operational or still working. Operational status active. So let's refine the search. And here's all the answers for the International Space Station. The space surveillance catalog number is 25,544. So any one of these will do. They're all the same thing. Zara was the first module loaded. We can pick a different color for it. How about something that's sort of like green? Insert. I did hit insert and close. And close for now. So this is a map of April 1st at 7 o'clock in the morning on some clock. I'm not sure which time zone. This is a two-dimensional map showing where the satellite is directly overhead at different moments in its orbit around the Earth. Here's Cerritos, and here is a nice three-dimensional view. So with the three-dimensional view, with your mouse, you can click and drag and rotate the Earth, and it shows that at 7 o'clock, it was in units of universal time. So I'm going to change my scenario units by double-clicking on it and choose for the time, choose for the units for time. Do I want to do this? Choose the, wow. I want to set it for the local time, and I forgot how to do that. How about the units? Okay, I'm looking at, these are all the choices for time. I'm looking. How about Gregorian local time? That would be this one. And try OK. That didn't really change it, did it? Oh well. At 7 o'clock in the morning, I would expect us to be in sunrise. And this is showing us 7 o'clock as being nighttime. So that is set for what's called universal time. Oh well, here's the point. When you hit the play button, woo, everything is now working. And by the way, the stars that you see there, those are all the actual stars where they are in the sky. They're not just random dots. Every star is one of the stars in the sky. So I'm just looking around to see if I can recognize a pattern that I can share with you. So let me look towards the North Pole of the Earth. And somewhere over the rainbow, maybe. Oh, 3-minute break. Okay, kids, good news. Take a 3-minute break. Here we go. All right, we've done our 3-minute break. I'm going to try to, I was trying to show you recognizable star patterns as we look at the Earth, and I was looking for the Big Dipper, and I don't see it handy, so too bad. Let's just move on with this. Here's the Earth, and there's the International Space Station. And let me change my view to home, so it's just great. Okay, so as the space station goes around the Earth, can you see it? The answer is generally no. It's on the other side of the planet, it's below the horizon. A couple things why you might not be able to see it. So let's add a sensor to Cerritos that is looking for the space station. So under Insert, I'm going to choose New. I'm going to add a sensor, and I'll just, I'll define its properties. Okay, and the sensor is associated with City of Cerritos. I could either make it on the satellite, or I can make it, so what is it? 45 degrees means it can look all the way to the horizon, and let's make it only look 40 degrees. Simple conic sounds fine. Close. So now notice how it's all funny colored? That's because the sensor is staring at us. So if I change my field of view, zoom out a little bit, there's a cone showing everything out in space that you can see from Cerritos at this moment. Okay, so I'm going to ask it when can it see the International Space Station. So I go to Analysis and I select Access. I select the space station. I hit Compute and Close. So the short answer is, in this one day, it never sees the space station. Or in this one orbit, I guess, this one day. And I can speed up this animation. We go through the full day. The Earth is rotating, and I think the day is going to end before the space station passes within range of Cerritos. Oh, maybe. There. Okay, so here is a time when the space station is within view of Cerritos, except it's not showing it as being in view of Cerritos. Now that's interesting. Why not? Oh, because it's underneath the cone of visibility. Let me try to show it to you this way. I'm going to zoom to Cerritos, zoom out a little bit, and then rotate my viewpoint. So there's the city of Cerritos. Here's this thing looking up. And if I zoom out enough, you'll see the satellite mist being visible from Cerritos. So let's make an adjustment on the sensor because it should be able to see it. Simple conic. Let's make it back to 45 degrees. Apply that. See what happens here. Let me make the change so you can see it again. So at 40 degrees, the cone's a little narrower. At 45 degrees, so look at the cone. 3, 2, 1. Boop. See, now it's wider. I'm going to make it targeted, and the target is the space station. So now, anytime that the space station is within view, it'll show up and say, look, see? So it is in range of Cerritos at this time. And this is all real information, by the way. So yes, the real city of Cerritos, yes, the real International Space Station, and yes, on April 1st at 7:56 and 40 seconds. However, that's not local time, right? This is Greenwich Mean Time, or Universal Time, it's called. So I'm going to reset my scenario. and say, well, great. So as the satellite goes around, let's get back up to it. Even faster. I'm in a hurry. So this time, I'm going to back it up and say, look, step, 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 step. Sure, this says the space station is within range of Cerritos High School at this time. But this is daylight. You can't see the space station during daylight. So I'm going to add a constraint to the city of Cerritos. Double click on Cerritos in the object browser and go down to constraints and select basic. And the constraint is I'm looking. Oh, it's not under basic. It's under, let's try sun. Lighting and must be in the umbra, which means you're in the shadow of the Earth. So when I apply that, whoop, maybe that should have updated things to show that I can only see the space station when Cerritos is in darkness. And it looks like it did not actually do that. Because here it's showing Cerritos is in daylight when it sees the space station. Like right there. So maybe it's the sensor I need to constrain, not the city of Cerritos. Let's try this again. So for the sensor, lighting, umbra, apply. Boop. And sure enough, the only times it can see the space station now happens to be when Cerritos is in nighttime. And we have to go forward a bit more time to get to that situation. So it's sunset on the East Coast, in the Midwest, and let's back up right there. Right there. Okay, so here is a time when the space station will be a visible fly above Cerritos while Cerritos is in nighttime. But now there's another problem, and that is, what if the satellite is in the Earth's shadow as well? So on the satellite, I'm going to bring up its properties, and under constraints, sun, lighting, I'm going to say direct sun, and I'm going to move the window so that when I hit the apply button, boop, now you can see, okay, there's only one time, well, twice, in between today and tomorrow when you can hope to see the International Space Station. And that is after sunset and while the space station is still in sunlight. So if you want to have fun, you can use this software program and make this customized from your home and play with the rest of this program where you can put in ships and missiles and satellites and aircraft carriers and all kinds of fun toys. But if you don't want to do all that stuff, you can just go onto the internet and go to Heavens Above, for example, heavensabove.com. I've shown you this one before, except that's heaven, not heavens above. Drat. Heavens above. Here's the easy way to do things. You could say, click on 10-day predictions for the International Space Station, ISS. And of course, this is for hopefully our location on Earth. Let me Let me verify where we are. The default is to say that we're in Africa. So this is clearly showing uh, that we're in Cerritos, and therefore good enough. So when we click on ISS, it says, here it is, and nicely, it's in local time. So local time, April 1st, tonight at 9:03, the space station is going to come above the horizon out of the northwest. At 9:05 and 7 seconds, it'll be at its highest point on this pass, 21 degrees above the north horizon. And then that's the same moment that it goes into the Earth's shadow, ending this particular thing. So that would match roughly this pass here that you see. So right there, that's 9:05 and 7 seconds. If we were to slow it down, go step, step, 9:07, and then it's gone. So STK is showing the very same result. Here's this pass that the website is showing, except you don't have to do all the work of setting this up, or you miss out on all the fun of setting this up. Back to the website, if you click on this little hyperlink, it'll show you a map of the sky and where to look to see it. Yeah, so here it is. This circle represents the entire sky. When you hold it directly overhead, the bottom of this page is south. If you turn to face the west and rotate this page clockwise 90 degrees so that west is towards your feet as you look at this sheet of paper as you face west, then that matches this part of the sky. If you decide to face north, then you should turn the paper so that the top of it, oh, I have a pen. So this would be north. Oh man, I'm not going to do this. It's too slow. Oh, great, I have a mouse. What can I do with my mouse? Oh, I can highlight things. Nice. Okay, so if this part of the page faces north, then, there is the North Star. It is not the brightest star in the sky. Over here is the path of the space station. Tonight at 9:02, it'll be coming above the northwest horizon. At 9:03, it'll be passing by the constellation Cassiopeia. And at 9:05, it'll disappear into your shadow directly underneath the North Star. So if you want to be sure that you're seeing the space station and not a jet, it'll go into shadow. It'll suddenly become much dimmer right as it goes underneath the North Star, or slightly east of it, said 22 degrees. I encourage you students to go enjoy learning some astronomy here, doing stuff like this. Okay, other stuff you could do while you're out there. Can you find the Big Dipper? Let's see. That would be this one. Can you find the Big Dipper? Oh, wow. I didn't know you could zoom in on it. Oh, look at that. This is, if you have binoculars, this is the bowl of the Big Dipper. These two stars are called the pointer stars, and we don't care today. Wow, interesting. Gemini the twins, Orion the hunter, Leo the lion. These are things you can spot this evening after sunset. Playing with STK, I guess if you're going to take the trouble to play with it, a few things more that I can tell you about it. for the space station, if you click on it and choose to zoom to it, there is the model of the space station. And as you go forward through time, you should notice that the solar arrays are rotating. They are rotating at the same period that the satellite orbits the Earth. So when the satellite gets out of shadow, of course, it's in shadow throughout my whole. Let's just reset this. Boop. Okay, and then play, and then go forward so fast. There. So when the sun's above the horizon, the solar rays are facing the sun the whole time. And they just keep them rotating even as the satellite is in the Earth's shadow. So what you're going to see is the sun set, there it goes, and now the solar rays are in darkness, but they're still pointing towards where the sun would be if the Earth weren't in the way. So here comes sunrise, and the solar rays are all good, ready to face the sun. Boop. On the space station, this is a nice high quality model showing a Japanese module. By the way, we can make this bigger. Showing a Japanese module, airlock, observation stuff, crew quarters. Now what you can do is you can put any model you want into any STK object you want to. So for example, yes, this is the International Space Station, but I can replace it under model with anything I want. So here's a whole folder of different spacecraft. And you probably don't know any of these. But the point is, if you go up one level, you could put in a ship, right? Where would that be? Under C. You could put in an aircraft carrier instead, boop, and just apply it and look at it. And so now, instead of a space station, oh, it's an aircraft carrier. How interesting. Yes. Okay. And let's back it up, get it in a little bit of whoops, forward into some sunlight, maybe. So it doesn't change the name of it, but it just changes the object that's displayed. You could replace it with some other fun thing. I'm going to pick a missile. So under model, I'm going to put in a missile. How about a Hellfire? Sure. Okay. Now, this is kind of in my way. So I'm going to make this smaller and apply it and zoom in. Oops, zoom in. So here's this missile. Great. Well, you can articulate these things. And so that means if you go down to articulations and view the articulations, this one doesn't have much, but you can turn on the flame by selecting it, and there you go. So you should see, oh, there's the missile firing away. And you can make flame bigger and brighter. Okay, so there you have a Hellfire missile burning away. If you get into playing with this enough, then yes, you can make movies where the objects animate themselves during the movie. So, for example, the missile can start and launch with flame coming out, and it burns, and after, let's say, a minute, it shuts off as the animation plays. So, okay. And this one just probably makes the whole size. Oh no, you can tilt the angle of the missile relative to the direction of motion. So you can move it and yaw and pitch and roll. That's nice. Okay, so that's something fun that I like showing to students. If you want to, let's go to home view. Here's the Earth. If you want, usually an exercise I have my students do is to launch a missile at somebody. And so, for example, that would be insert new missile. And I think I have to tell it where I'm starting from. So let's start from Cerritos. And then I have to tell it where I'm going to. Pick your favorite country. Oh, let's say, oh, sure. Ah, there goes Brazil. And close. So on the save changes, yes. So on the 3D world, you can see that the missile is going to go way up into the sky and come down. In the 2D world, that's the ground path directly underneath the missile. So if we set it and launch, there goes the missile. Yes, and off it goes to hit eastern Brazil. Nice. In darkness. So before sunrise, the missile's coming down, and that's all it is. It's just the analysis that goes with it. Now, if you want to have more fun, what you would do is you could zoom in to the missile, your view, and so now you're seeing from the point of view of the missile as it approaches a target. And thanks to Bing Maps, it's bringing up the details so you can see exactly where it's going to hit. Nice. So it's going to be hitting that part of the country. And then what I normally have my students do is say, okay, now 1 hour later, have the rest of the world respond by sending missiles back to the United States, maybe even Cerritos. So that's a little exercise in learning to use STK. And then if you want to get super advanced, do stuff like learn how to turn the flames on as part of the animation that takes place, not with you moving the slider, but you writing the instructions for the program to follow that says, okay, when it gets to this point, turn on the flame for the missile. And missiles usually come in multiple stages. So if we bring up the model and we view the articulations, this one only has flames. That's it. Nothing more special about this particular missile. And usually the missile is not flaming as it comes down. It's only flaming during launch. So it's stuff you can play with. Everything I'm showing you right now is freeware, so you can keep it forever. It does not run on a Mac. It only runs on PCs. And uh, in my other courses, aerospace engineering and AP Physics C, they're expected to learn how to use this program a little bit and have it apply to calculations for satellites and changes in satellite orbits. Okay, so there it is. It's a lot of work, but it's freeware. And it's a stepping stone. So if you decide that maybe you like engineering after all, there's a satellite or constellation I could write. That's Coronas. Coma Berenices is the name of this constellation. Great. Uh, then here's a step that you can take on your own to begin to learn about this stuff. And if I rotate my view just right, there's the sun, here's the moon. If I make the moon between the Earth and my point of view, then as I zoom in towards the Earth, yes, you start to see the details. about the moon. Okay, and yes, you can do space travel in the sense that Boeing uses program for launching a real rocket. That you can do scenarios where you travel from Earth to Mars or Earth to the moon. It's not easy. They have tutorials. There's no undo button. So if you make a change and you don't like it, you have to remember what it was like before you changed it. Also, you can only have one scenario open at a time. Unlike Word, where you can have multiple documents open, here only one. You can create movies and export them and post them on YouTube and stuff. So there's fun stuff you can do, and this concludes my lecture for today.